Have you ever stopped to wonder what keeps everything, well, on? What keeps Netflix streaming, your bank app working, your messages sending 24/7 without a single hiccup? It's definitely not magic. It's this hidden science called uptime, and believe me, it is the invisible force holding our entire digital world together.
But let me ask you something. If a service you really depend on told you it was 99.9% reliable, you'd probably think, hey, that's pretty good, right? I mean, it's almost perfect. But in the world of uptime, almost perfect can be a total disaster.
Just look at this. 99.9% uptime sounds fantastic, but it actually means your favorite service could be completely down for almost 9 hours every single year. Now, compare that to 99.999% uptime. That's the gold standard. We are talking about just 5 minutes of downtime in an entire year. The difference isn't just big, it's absolutely staggering.
And that massive difference, that is the science of uptime. And understanding how that's even possible is exactly what we're going to do right now. We're going to pull back the curtain on the incredible engineering and the philosophy that keeps our digital world online. So, first things first, let's start with the basics. Uptime is just a simple way of saying the percentage of time a system is available and working correctly. But the way we talk about it, the language we use to measure it, is incredibly precise, and it all revolves around the number 9.
This chart right here really puts it all into perspective. It shows you just how demanding the world of high reliability is. At 2 nines, or 99%, you're looking at over 3.5 days of downtime a year. That's a lot. But as we add each 9, the amount of acceptable downtime just plummets. By the time we get to 5 nines, we're talking about only 26 seconds of downtime allowed per month. It's just incredible, isn't it?
So who's the referee here? Who sets these standards? Well, that would be the Uptime Institute. Honestly, the best way to think of them is like the Michelin star system but for data centers. You know those huge, high-tech buildings that house all the servers? They are the completely unbiased judges who go in, inspect these places, and award them an official rating for reliability.
And their most famous rating system is the tier standard. Now, to make this super easy to understand, we're going to use an analogy. We're going to compare the 4 tiers of data centers to different kinds of gyms. From, say, a basic setup in your garage, all the way to a state-of-the-art lab for superheroes.
All right, first up we have Tier 1. This is your starting point. It's the most basic level of infrastructure you can have. Just think of it like a simple gym you set up in your garage. Now, the most important thing to know about Tier I is that there is absolutely zero redundancy. It has one power line, one cooling system, one of everything. So if that single power line gets cut, or the air conditioner breaks on a hot day, the entire system goes down. The gym goes dark, and your workout is officially over. So how do we make that better? Well, that brings us to Tier 2. This is like upgrading your garage gym. You've decided, okay, I need to be a little more prepared, so you've added some backup equipment. A Tier 2 facility adds some redundant components, like maybe a backup generator. And that's a great step. But, and this is a big but, it still has single points of failure. You might have that backup generator, but if the single power cable that runs from the generator to your servers gets damaged, that backup is completely useless. It's better, for sure, but it's still surprisingly fragile. Okay, now we're entering the big leagues. Tier 3 is a massive, massive leap forward. We're not in a home gym anymore. This is a high-tech training facility for professional athletes, and it is designed for zero interruptions. The whole philosophy changes right here.
And the magic concept that makes it all possible is called concurrently maintainable. It sounds fancy, but what it means is incredible. You can take any single piece of equipment offline for repair or replacement, a generator, a cooling unit, a power line, you name it, without ever affecting the servers. There is no such thing as planned downtime for maintenance. It just keeps running.
So what on earth could possibly be better than that? Well, welcome to Tier 4. This is the absolute pinnacle of reliability. Forget the pro athlete facility. This is the secret underground lab where superheroes build their gear. It is designed from the ground up to be completely, utterly unstoppable.
The key term for Tier 4 is fault tolerant. This means the facility can withstand any single unplanned failure and just keep on running, automatically, like nothing ever happened. A power line could get cut by a backhoe, a cooling unit could completely fail, and the servers would never even notice. This is the level of reliability you need for things like global stock exchanges or air traffic control systems, things that absolutely positively cannot fail.
So you're probably wondering, how is this level of reliability even possible? Well, it's not any one single thing. It's really about mastering 3 different but interconnected areas of engineering. You can think of them as the 3 pillars that hold up the science of never failing.
The first pillar is power. You have to have a constant, clean flow of electricity, period. This means having giant battery rooms. That's your uninterruptible power supply, or UPS, for an instant, seamless backup. For longer outages, you've got these massive diesel generators ready to kick in within seconds. And for the ultimate in reliability, you use a design called 2N, which is basically a complete mirror duplicate of the entire power system. It's like having a twin for absolutely everything.
The second pillar is cooling. You have to remember, servers are basically just really expensive toasters, and they generate a tremendous amount of heat. So you need industrial-scale mechanical engineering. We're talking huge air conditioners, giant chillers, and a really scientific approach to managing airflow, with hot aisles and cold aisles to make sure every single server stays perfectly cool.
And the third pillar, which you could argue is the most important one, is process, the human side of things. See, you can have the best facility in the world, but it can all come crashing down because of one simple human error. So everything, and I mean everything, is governed by meticulous procedures and checklists, from routine maintenance all the way to handling a catastrophic emergency.
All right, so we've got the tiers of reliability and the pillars that support them, but how does this all come together in the real world? Well, that brings us to the high uptime playbook, the core strategies that turn all these principles into reality.
First, you build redundancy in everywhere, so no single part can ever take you down. Second, and this is a big mental shift, you design for failure. You just assume things will break, and you build systems that can handle it automatically and gracefully. Third, you practice safe releases. You're incredibly careful and slow when you make changes to the system. And finally, you master observability, which is just the ability to see deep inside your systems and spot trouble long before your customers ever do. And that really brings us full circle. From your banking app to your video calls, your entire digital life runs on these principles, inside these invisible, amazing facilities. So the next time you use an app that just works, take a second to appreciate the science of uptime. And ask yourself this: what level of reliability, what tier, do you think your digital life truly deserves?